Today we're going to take a look at section 3.1, symmetry and coordinate graphs, and we're going to focus on even and odd functions. So the first thing we're going to do here is a short little investigation. We are going to use our calculators to graph these and then sketch a graph under each one. So on your Inspire here, we can click on the scratch pad key over here on the left. And it brings up our scratch pad. If we want to switch over to the graph, we can press that scratch pad again. And let's see, our first graph was x to the power of 4. Alright, so we have a parabola shape there, so we can do a quick sketch of that. We had our parabola. Let's bring this calculator back up. We can press our tab key again, arrow up to get that F1, control clear it, and let's see, now we have 2x to the power of 4 plus 2x squared. Alright, let's make a sketch of that. Alright, our next one here, again tab, we can arrow up and clear it, and what do we have? Negative 3x to the power of 5 minus 2x to the power of 4. Oops, and it looks like some things are in the way there, and that was to the power of 6. We need to arrow out of that exponent. Minus 2x to the power of 4. Okay, so this one is open down. And then that last one, 2x squared minus 5. Oops, tab. Some of you guys might recognize this, that it's that parabola, and something's messed up here. My bad, it's squared minus 5. Okay. So let's see. Now we want to answer a couple questions. What type of symmetry does each have? So if you guys notice here, it's symmetric across the y-axis. If we folded it in half, we would have the exact same graph. And what is special about each of those is that, yeah, those exponents were all even there. And these are called even functions. Now, if you don't have a calculator, that's just fine, because we can prove this algebraically. If you notice when we look at our graphs here, if this was x equals 1, and here was x equals negative 1, our y value is the same, and it works for all of these, because they're symmetric. So if this was negative 5 and positive 5, that y value is still the same. So algebraically, f of x, for any x value, it's the same as when we plug in that opposite of x. We get the same y value. So let's take a look at a couple of these and proving them algebraically. Our letter A, we had f of x equals x to the power of 4. Well, if we plug in a negative x, f of negative x, we'd have negative x to the power of 4, but we know anything to the power of 4 is going to be positive, so that negative, we could say it's the same as x to the 4th. So now we can see here, f of negative x, these two are the exact same, so it would be even. Let's take a look at letter B, because that one's a little bit more complicated. We had f of x equals 2x to the 4th plus 2x squared. And if we have f of negative x here, we plug that in. We have 2 times negative x to the 4th plus 2 times negative x squared. So we look at this, okay, so let's see, let's simplify. So f of negative x equals, again, this is to an even power, so that negative is the same as when it's a positive, plus 2, there's another even one, x squared. So when we look at those two, we get the same thing. So again, this one would be even. The next thing we're going to do is we're going to take a look and graph some of these odd functions here. So our first one was x to the power of 3. And you might remember that graph from advanced algebra. So next we have x cubed minus x. So that's nice. We can just add on a minus x. And it looks like that cubed function, but a little bit different around the origin. Our next one, that's a longer one there. So we'll clear this out. So we have x to the power of 5, arrow out of the exponent this time, minus 3x to the power of 3 plus 4x. Oh, that one is interesting there. We'll see how well I can draw that. So we had kind of a little... that doesn't look too good, but we'll go with it. And then that last one here, we have negative 2x to the power of 3, arrow out of the exponent, minus 5x. All right. So it's going kind of the opposite way of this one. What type of symmetry do these have? They're called odd functions. And let's see, you may have noticed here that all of these would be the same if we rotated them 180 degrees. So if I rotated that 180, that graph looks exactly the same. Let's see if it works for this one here. Yep, we can rotate those 180, and it's the same. When you can rotate it 180, it's said to have symmetry about the origin. And these exponents here, you'll notice that they were all odd. So we can verify this one algebraically as well. So instead of, if we were to look at a couple of these points here, if this was 1, negative 1, this one is negative 1, 1. It's rotated there. So when we take the opposite of our x value, we get the opposite of our y value. So that is written as when we take the opposite of our x value, when we plug in a negative x, our y value is the opposite. So if we look at proving a couple of these, we'll take a look at a few. So we had f of x equals x cubed. So if we take the opposite of f of x, that's just going to be the opposite over here, so the opposite of x cubed, and that negative needs to stay since it's a odd power. And then if we take f of negative x, let's see, we plug in negative x, we get negative x cubed. And we can see that these two are the same. So let's take a look at b here. We have f of x equals x cubed minus x. So to prove this, f of negative x equals the opposite of f of x. So f of negative x, so we'd have negative x cubed minus negative x. We're going to see if that equals the opposite of that, so the opposite of x cubed minus x. Let's see if we simplify. Well, that negative can come out in front since it's an odd power. Negative and negative plus x equals, we distribute that negative, negative x cubed plus x, so it's odd. Let's take a look at one more. We'll take a look at letter C here. We have f of x equals x to the 5th minus 3x cubed plus 4x, and we want to see if it's odd. So f of negative x equals the opposite of f of x. So we can plug in that negative x. Negative x to the 5th minus 3 times negative x cubed plus 4 times negative x. Does that equal the opposite of our entire function here? X to the 5th plus 3x cubed plus 4x. Well, now we just have to simplify. That negative can come out in front, so negative x to the 5th. If we bring this negative out in front, it would become positive 3x cubed. Bring our negative out, negative 4x. And if we distribute, negative x to the 5th minus 3x cubed minus 4x. And as we see here, they should turn out to be the same. Oh, yep, I had a plus there. That's why. So when we distribute, it's positive there. So you always got to watch your signs there. All right. So the last thing we're going to take a look at, let's say if we have a function, and let's say we don't have a calculator. We can't graph this and take a look at it. We have to check to see whether it's even or odd. So again, our even, f of x equals f of negative x. So f of x, we have x cubed minus x squared plus x, and then we have to plug in that negative x. Negative x cubed minus negative x squared plus negative x. Well, we can't simplify that side. And this side, our negative can come out in front. And this negative we don't pull out because if we square it, that's the same as a positive. And then we have this minus x there. So it's not even. And we can check our odd. F of negative x equals the opposite of f of x. Okay, so let's plug in that negative x cubed minus negative x squared plus negative x. Does that equal the opposite of that entire function? Negative x cubed minus x squared plus x. Well, we can simplify. The negative can come out in front. Again, that negative squared, so that's just the same as x squared minus x. Equals, we distribute negative x cubed plus x squared minus x. It's kind of a mess there. So we can see that, no, what happened here? Oops, sorry about that, guys. Negative x cubed plus x squared minus x. So we can see that, no, it's not odd. It's neither. So for your assignment tonight, you'll be taking a look at that worksheet, 3.1 worksheet, and looking at odd and even symmetry.